Hello everyone. Today we will discuss about artificial neural networks. So first we will learn some of the concepts of neural networks. So artificial neural networks are inspired by an information processing model of mind, or we can also say it as a brain. So every neuron receives information from many other neurons, processes it, gets excited or not, and passes its state information to other neurons. And artificial neural networks are versatile systems used for pattern recognition, forecasting, and prediction, classification, regression, clustering, association, optimization, and it is also used in many application areas like finance, marketing, manufacturing, operations, information systems, etc. So these are some of the business applications of artificial neural networks: stock price prediction, character recognition, as in recognizing handwritten text, classification problems such as loan approval, and this is a simple biological diagram of neurons in the brain cells. So I think you are all learning the biology. Then this is a modeling of a neuron. So a neuron receives inputs from other neurons and produces an output for the following neurons. If you see here a single neuron structure, so here we have a summation unit, means it receives the inputs. For example, here is receiving x1, x2, x3, x4, x5 inputs, and each input has some weight like w1, w2, w3, w4, w5. So we are summation unit will sum all the values, all the inputs, and apply the required information, and output is fed to the other neurons. So this is a simple model. So now we will discuss design principles of artificial neural networks. The neuron or processing element is a basic element, and ANN is a multi-layered model with hidden layers and parallel processing. ANN processes inputs from many neurons, assigning different weights to each input and sum ups as shown in the diagram. And the summed output is transformed into binary input yes or no using a sigmoid function and fed forward to the next neuron. So learning in artificial neural network occurs by changing the underlying relationships between input and output in response to the results of ANN. Again, next we will discuss about the artificial neural network architecture. So artificial neural networks are composed of large number of highly interconnected processing elements, and these are called as neurons, working in a multi-layered structures that receive inputs, process the inputs, and produce an output. So here we have an input layer, and one more is a hidden layer, and finally neuron 31 is producing the output. So how to test a trained artificial neural network model? So here the data is split into three parts. Okay, one is training set, validation test, and testing set. So in training set, data set is used to adjust the weights on the neural network. In validation set, data set is used to minimize overfitting and verifying accuracy. And in testing set, this data set is used only for testing the final solution in order to confirm actual predictive power of the network. Uh, so there are many validation techniques like less bias and time consuming. So some of the most popular architecture in multi-layered processing, this is feed forward signal to next layer and back propagate the result to the ensure learning. So artificial neural networks follow a supervised learning process. This is a three-step process. So compute temporary outputs and compare outputs with the desired targets, adjust the weights and repeat the process. So first it will compute the output and we'll check whether the desired output is achieved or not. If it is yes, then stop learning. Otherwise, it will go to the no section and we have to readjust the weights of the inputs, and finally we will produce the output. Again, it will come to the desired output is achieved or is checked. So this keeps on going until we get the uh, desired output. Okay, so these are different application types of artificial neural networks. So classification we can do it, regression we can do it, clustering we can do it, and association we can do it. So what are the advantages of artificial neural network? So able to deal with highly non-linear relationships, not prone to restricting normality or independence assumptions, can problem types handle variety of problem types, usually provides better results compared to its statistical counterparts, handles both numerical and categorical variables. So these are some of the disadvantages. They are deemed to be black box solutions lacking expandability. It is hard to find optimal values for large number of network parameters, and it is hard to handle large number of variables. Training may take a long time for large